So this is the fourth day for our Chapter 8 on the harmonic oscillator, and I'm just going to use this video to introduce the two assignments for the chapter and the two final assignments actually for Calc8. And they're both in your note booklet for this chapter. The first assignment is the bouncing bob. You're going to be using page 11 of the notes, and I'll just show you that that's this page right here where you're going to make bob bounce to the beat of your music. You're going to be using that page to determine the correct mass for the oscillator to bounce to the beat of your music. When you've got that page totally filled in, you can just send me an email of your completed page, and you will also need to send in that email an MP3 file of the music that you're using or a YouTube link to the music that you're using. Be careful if you're going to send me the YouTube link. Make sure that you're actually listening to that YouTube version of the song. If the YouTube version is like a live version of the song and you've got the studio version, they will be slightly out of time and the process won't actually work. So you have to make sure that whatever music I'm getting from you, it's actually the music that you've done with the timing. I will set it up and test it here. I will film it, and then I will post your video in the All Resources folder so that you can see how well it works. I don't want you to worry about getting it wrong. You can have multiple tries to get it right. In the end, if you get it to work, you're going to get 100%, right? So this is one of those try it until you get it deals. And again, this page here is the one that you'll want to work through. The spring constant is the same one that I was using, 15.35 newtons per meter, and the mass of the spring is 65.57 grams. I would suggest you do at least 50 beats. 50 or 60 is probably a good plan. And if your frequency is a little bit too low or too high, if it's lower than 0.9, you can double it, or if it's higher than 1.8, you can cut it in half, and it'll still look quite natural as it bounces to the beat of your music. You do have to, of course, include the mass of the spring. It's a real-life story, so you have to factor in 1/3 the mass of the spring, much the way that I did the examples in the notes with the two music tests that I was showing you. So that's the first assignment, and then the second assignment is sometimes referred to as the big proof. The first thing you're going to have to do is just get ready to do this. You'll probably want to find like a phone partner that you can be just talking to them over the phone or any other social media, just kind of going through this. It is okay to have a partner and kind of do this together. You'll each be producing your own big proof, but it's helpful to have somebody else that you can be talking to. So grab some tape. And most people find they need about 12 pieces of paper to do this. It's going to end up being about the size of your desk. So you'll want to start taping some paper together. You might get it done only 3 across, but most people find that in kind of the landscape format, they need about 4 across, usually about 3 deep in order to get it to work. And once you've taped them together, you can flip that over so you don't have to stare at the tape, and then you've got this beautiful canvas to work on to create this masterpiece. And the goal is to just prove the solution that we talked about in the previous video works for the damped oscillator. Not trying to show why that's the solution, just verify that it does actually work. But definitely work through this task with other people, right? That way you can say, hey, on this line, do you have this, right? And you can kind of read it off. There's going to be time to do this over the next couple of weeks, so you'll want to make that phone contact with somebody and see how it's going. So the general idea, and it's laid out on the last page, but the general idea is that this should be the solution to the damped harmonic oscillator. And as the assignment states, okay, so I'm just going to kind of flash back and forth to it here. The very first thing you'll want to do is just expand the brackets there on that particular solution, just to get rid of those so you have a deal there with 2 separate terms, the cosine term and the sine term. So it'll look like this by the time you've expanded the bracket out. And we're just going to verify it works, and that's going to involve taking a couple of derivatives and then substituting into the differential equation. Before you do that though, be careful, because this is definitely a couple of cases of product rules. You have one thing here which varies with time because of the exponential, right? Because of that t that's right there. And it's multiplied by another thing that varies with time because of the t inside the cosine. And then the same thing over here. This term here is a term that has a t in it, and then the sine term has a t in it. So when you go to do a derivative, you're going to have, being a derivative of these two terms that are here on the page right now, you're going to have two terms from each one of them. So you're going to end up with 4 terms by the time you carefully do a derivative of the solution that we think is right. Because you'll be saying, oh, okay, well, what's the derivative of this, but leave that one alone. And then you're going to reverse it around. And then you're going to say, oh, okay, well, what's the derivative of this? And leave this one alone. And in that product rule, you're going to see the chain rule is going to be kicking things out at you all the time. You're going to see omegas coming out to crash the party. You're going to see this negative b all over 2m coming out to crash the party. So be really careful. Slow and steady wins this race. You should have 4 terms when you found the derivative, the velocity for that bouncing damped oscillator. Then you're going to do another derivative, and because of the product rule, you're going to end up with twice as many terms. So the second derivative is actually 8 terms long. And again, the chain rule is going to throw some things at you out front. The goal is to make sure that this differential equation actually works. So when you've got your 2 derivatives ready to go, the plan is to take your answer for this and substitute it in here on that left-hand side. You'll take your answer for this, all 4 terms of it, for that velocity, and it's going to go in here. And then this negative b over m is going to get multiplied by it. And then you're going to take the answer for x, which is this, just 2 terms long, and it's going to go in here. And of course, this negative k over m is going to multiply by it and then distribute out. So you have to be super careful with all of your minus signs in order to get this to work. And then we're just going to show that indeed the left-hand side of this equation, which is really just from physics from Newton's second law, is equal to the right-hand side. And we're going to do that by slowly and carefully working it down until we get 0 divided by 0. So the instructions are fairly well laid out here on this last page, right? So again, it says, all right, expand those brackets out, take a derivative, take another derivative, and how many terms you're going to have in there. And then you're going to substitute into that differential equation. There are some ground rules, though. You can't just look at it and go, yes, I've looked at it, and it all goes away. It's just 0 equals 0, right? You have to actually only do one step at a time. So please do look through the ground rules. You can only do one mathematical move at a time, and I've kind of demonstrated that here just with some random algebra for how many lines it would take to get it down to 0 equals 0. Even though this very first line in my little sample proof with random algebra is 0 equals 0, you can't just go, oh yeah, it balances. You have to actually be very methodical about where the terms are when you actually cancel them, when you reduce this down. So again, just looking at the instructions, the left-hand side will equal the right-hand side when you're done. Some hints. I said 2 hints, and that's actually not right because I wrote another one in there. So at least 3 hints. Number 1, you're going to find it's a lot easier to use color to stay organized because there are so many terms, 14 of them, and actually a couple of them split apart and become 2 more. So you're going to end up with 16 terms. Some of the terms have A's, capital A's, and some have capital B's. Some have cosines and some have sines. And I've seen a lot of success from students who try to get organized by grabbing some colored pens, and anytime they, for their proof part at the bottom, anytime they've got an A and a cosine, maybe they write it in one color of their choice, maybe blue. Any terms that are A's multiplied by sines, they write in a different color, and then B cosines, a 3rd color, and then B sines in a 4th color. And what you'll find is that each color takes care of itself. So somehow all of the blue terms on your paper will go away. And if you're stuck and you're like, whoa, I'm ending up with some terms that won't go away, you can look back at the beginning and kind of follow it through until you've got it right. So color really, really does save you some time there in the end. Second hint. You're going to see omega d's all over the place. They pop out because of the chain rule when you take derivatives. They're everywhere in this story. And just leave them. Let them just sit there. They're just constants unless you see an omega d squared, which you will a couple of times. And if you see some omega d squareds, you can actually put in this instead of omega d squared, because we know that omega d is the square root of the k over m minus b squared over 4m squared. But if you do put this in for that omega d squared, you need to factor that or simplify that open. You need to distribute. Okay, and that's where you're going to end up with 14 terms turning into 16 terms. Last thing, there's going to be a couple of times where some things look like they might be ready to cancel. You might look and go, oh, those are identical. I'm going to throw them away. And they're not actually going to cancel. They may actually add up and cancel with a third thing. So you'll end up with at least twice, I think, with some trios of terms that will work together to go away. And as just a simplified metaphor, I've put down here 1/4 plus 1/4 is equal to a half. You might be tempted when you see these to go, oh, look, there's like a quarter and there's like a quarter. They go away, but actually they don't. They have the same plus minus sign to them, and they coagulate together to make something as big as a half, which cancels with another half in a different spot. So watch out for that. When you're finished with your masterpiece, send me a very clear picture of the whole thing. So hold your phone very carefully and take a shot. I would be able to need to zoom in and see the terms. So, just take a look at your photo, kind of zoom in on it. And if I can see the terms, that's great. If you need to do it in 2 photos, that will work too. The timeline is very distant. This is the final thing to do for the course, like for the entire course. The next chapter we're going to do, if we want to call it that, is just some extra stuff for you to see and maybe try out for fun. But these assignments, you'll have some time. And I have actually budgeted the last part of this week and all of next week to get this process done. So that should be enough time. If it's not, just let me know, and you can probably still be working on it. But I'm thinking that just to kind of keep you on pace, that's probably good. So looking at not the end of this week, but the end of next week, probably around May 15th, to have those all sent to me. If you do have the music ones done a bit early, start sending me those, because I will need some time to actually pour the water in, get the mass right, and test them and put the videos up. So that one, it would help me out if, as you go, you do start sending me the page of the music ones, this page here. Okay, when that page is complete, that would definitely help me out. You don't have to send me any part of this last page in the notes right here, just the photo of your final proof, big proof masterpiece. And that is it. There's no test for this chapter. Those 2 assignments are the assessment for this chapter. And I think in the end you'll find that they're actually a lot of fun.